Hello dear students, welcome to the class. So in today's class, we'll be discussing about the next chapter, that is semiconductor. The previous chapter we have studied is digital electronics, and we have studied the principles of electricity, network theorems and AC principles in the chapter. And also we have studied the passive electronic components. Then we have studied up to inductors, which is present in your syllabus. Right? In that chapter, whereas the transformers and the further topics, the transducer and all, is just removed from the syllabus for this academic year. Right? So now we'll be starting with a new chapter, that is semiconductor, and this will be the also the last chapter for you. Right? So we are studying about semiconductors. It is the most important part of the study of electronics because all the electronic components, ICs, transistor, diode, all the important components, otherwise as um, complex, otherwise as important type of chips, maybe microcontroller, microprocessor, all are semiconductor based components, otherwise chips we can say, right? So for that reason, what happens is studying semiconductors, understanding the concept of semiconductors becomes very important. While discussing in the first chapter, we have come across the word semiconductors, where we have seen that semiconductors are basically used are the most commonly used are germanium and silicon. Whereas again, over germanium silicon is most widely used type of semiconductor. So this is the basic type of semiconductor material that is used in device fabrication, and the very important devices are diode, transistor, even ICs, digital ICs, and also other important advanced chips, the advanced chips like microcontroller and microprocessor. Okay? So to understand all those components, otherwise to understand those uh, devices, chips or ICs, it is quite important to understand the concept of semiconductors. What actually happens inside it. So for that we will be studying the band theory. So for that we study band theory of solids. We study band theory of solids. Okay? So for that we need to understand about the structure of an atom. Structure of an atom. We know that solids will be having many and many atoms inside. Okay, billions of atoms are present inside a solid. That we will pick up one of the atom and we will try to understand the most basic parts of an atom. So it is basically the core is having the first band, it is having a second band. I'm taking an example of three-band atomic structure. Structure of an atom. Here, yes. I'm taking another example of the similar type of atom here. Right? So this is the core. This is having orbit number 1. Okay. This is the core. Okay. And around the core there are orbits, and this is the core. After the core, the first band, this band is having a orbit number as 1. The next one is having the orbit number as 2. The third one will be having We call it as valence band. Next time writing the orbit number, otherwise the identification for the orbit as B. Okay. Here also orbit 1, 2 and 3. Okay. Apart from that, each orbit will be having its fixed radius. Okay. So this is radius R1, this is R2, this is RB. Here, for this particular atom, okay, we name it as atom 1 and we name it as atom 2. So this is also having a fixed radius. Okay. Here. This is also having radius R1, R2 and R3. And energy levels. Energy level is E1, E2 and EB. Same way. E1, E2 and EB. Right? Here. So these are the orbit numbers. Right? So this is about the atomic structure. We are taking examples of two atoms, and here we need to understand the important parts of the atom. It is basically having a core, okay, and around the core there are fixed orbits, and the orbits are given numbers as orbit number 1, orbit number 2, and valence. The orbit, which is the last orbit for this particular atom, is called as what? The valence orbit. Otherwise, it is also called as the valence band. This is called as the first band, this is called as the second band, this is called as the valence band. Beyond that, there will be conduction band. It is having a radius of R1, R2, and RV respectively. Also, the energy level of the first band is E1, energy level of the second band is E2, and energy level of the valence band is EV. Okay, and the energy level of the bands is measured in electron volts. So I will just write the important highlight points. Billions of atoms are present in a solid. And about the atom, now further about the atom. First, about the core. Okay. So it is basically having, the atom is basically having three important parts, that is protons, neutrons and electrons. Protons have positive charge, neutrons are electrically neutral, and electrons have negative electric charge. Okay, it's having negative electric charge, and this is having positive electric charge. So these are the important topics, otherwise the important points for the important elements of the, you can say, important parts of the atom, right? So protons, neutrons, and electrons together are present in an atom. Now about the further each part of the atomic structure. The next important point that we need to know is protons and neutrons together form nucleus. Together form nucleus. Right? Together form the nucleus, that is also called as the core. The protons and neutrons together form the nucleus, also called as the core. Okay, and that is this part in the atomic structure. Right? Whereas for the electrons revolve around the nucleus in a definite order. Definite order. Here, in a definite orbit. In a definite orbit, the electrons are revolving around the nucleus, otherwise around the core. Here, these are the important observations in the atomic structure. Okay. So about these orbits, otherwise the bands. Start from the core. Okay, starting from the core, immediate next band after the core is called what? First band. Otherwise band number 1 is called first band. Okay. And this first band number 1 is has radius as R1, energy of even and band number n is equal to 1. N is equal to 1. Here. So what are we studied here? Billions of atoms are present in a solid, right? And that atom is basically having these parts, that is protons, neutrons, and electrons. Where protons are positive electric charges, neutrons are electrically neutral. Okay. Electrically neutral. Here, electrons have negative electric charge. Protons and neutrons together form this core, otherwise called as nucleus. Here, electrons revolve around the nucleus in a definite orbit. That means this is orbit band number 1, this is orbit band number 2, this is orbit called as valence band. Okay. Here, and immediately next band of after the core is called is called as first band. Otherwise, band 1. Okay, it is having a radius of r1 and energy of E1, and its band number is also 1. Here, the next band to that is called as the second band, and second band is having energy E2 and radius R2. Okay. And next to that, the band is called as the valence band. The valence band is having EV, that means valence energy, and radius as valence radius, and its identification for that band is N is equal to V. Here, so this is about the structure. Here, we need to know more about these factors, the more about the atomic structure. About the electron. Charge on an electron, this we have already come across, that is 1.6 into 10 to the power minus 19 coulomb. Otherwise, just capital C. Here, next, mass, of course, of an electron, that is 9.1 into 10 to the power minus 31 kg. Whereas radius is 1.9 into 10 to the power minus 15 meters. Okay. Of an electron and radius of an electron. This is about a single electron yesterday. And electrons are revolving around the orbit. Don't be confused with the orbit radius. And we are not representing any orbit radiuses because all the orbit radiuses are respectively different. This is the radius of an electron. Okay, one negative charge is having 1.6 into 10 to the power of minus 19 coulombs of charge. Okay, its mass is 9.1 into 10 to the power of minus 31 kg. Whereas its radius is 1.9 into 10 to the power of minus 15 meters. Okay. So this is about a single electron. A single electron that is revolving around the nucleus in a fixed, otherwise a definite orbit. Okay. So this is about the electron. Next, the highest occupied orbit. The highest occupied orbit in an atom is called valence orbit. There is valence band. Okay. That means this that is having some electrons. Okay. The highest occupied orbit, that means definitely occupied by the electrons. Okay. Highest electron occupied orbit in an atom is called as valence band, and the electrons present in the valence band are called valence electrons. Are called valence electrons. Clear? So, highest occupied orbit in an atom is called as what? Valence band, right? And the electrons present in the valence band are called what? Valence electrons, right? So about this valence electrons, what happens sometimes without any external energy, that means even at the ordinary temperature, some electrons will just jump from the valence band and they will move to the conduction. They will just jump from the parent atom and they will move to the conduction band for the conduction, even in the ordinary temperature. Right? And such electrons will be called as what? Free electrons. Here, so now we will study about the free electrons. Before that, this valence band is fully or partially filled. This is fully or partially filled, and the important thing about the valence band is that the electrons even at the ordinary temperature can just move to leave the parent atom and move to the conduction band for the conduction. Yeah. Now we will see about the conduction electrons, otherwise the free electrons. Here, so the electrons from the valence band that have moved to the conduction band are called as the free electrons or conduction electrons. Okay. Uppermost band after or beyond the valence band is called conduction band. What is called conduction band. Okay. Even the band that is beyond the valence band. Okay. Uppermost band after the valence band is called conduction band. Clear? Now, the electrons present in the conduction band are called free electrons. What these are called? Free electrons or conduction electrons. Free electrons or conduction electrons. Okay. So the uppermost band, even that is existing after the valence band, is called as the conduction band, and the electrons that are present in the conduction band are called as what? Free electrons, otherwise the conduction electrons. These free electrons are responsible for flow of electric current. Flow of electric current. this is about the free electrons in the atomic structure. Okay. Energy bands. Energy of bands measured in electron volts, EV. Here EV means electron volt. Okay. These are inner orbits. To understand the concept of semiconductors, we require three important factors, that is called as the valence band, and after that the conduction band, and then the forbidden energy gap. Forbidden energy gap. Here, and this will be the energy occupied by the inner orbits. Inner bands are inner orbits. Inner orbits are inner bands, right? This is the energy band structure where we need to understand basically the valence band, conduction band, and the forbidden energy gap. Then the valence band now is the energy level occupied by the valence electrons. The energy level occupied by the valence electrons is called valence band. Then conduction band. The energy level occupied by the conduction band by the conduction electron or free electrons. The energy level occupied by the free electrons is conduction band. Forbidden energy gap. The separation between the valence band and the conduction band. And the conduction band. Orbital energy gap measured in electron volts. Okay. Here, so valence band, the energy level occupied by the valence electrons is called as what? Valence band. And the conduction band is the energy level occupied by the free electrons. Whereas the quantum energy gap is the separation between the valence and the conduction band. Okay, and it is measured in electron volts. Okay, EV. Measured in EV called as electron volts. Right? So this is about the important energy bands that we need to understand for understanding the semiconductors, concept of semiconductors. Till now, what all we have studied? We have studied the structure of a dome, where we have seen that it is comprising of a core and fixed orbits are there around it, in which the electrons revolve. The core is basically formed with the nucleus. It is called as a nucleus, which is formed with the protons and neutrons. Where protons are positive charges, neutrons are electrically neutral, and electrons are negative electric charges. Right? So this is what we have studied about the atomic structure, otherwise the structure of an atom. And also we have seen that the in the structure of atom that it is having the radius, each orbit is having its fixed radius, and it is having its own energy level. Okay, and we have seen the examples of the first orbit having a radius of r1 and energy level of e1, second orbit having a radius of R2 and energy level of E2, whereas the third orbit having a energy level of EV and radius as R2, right? And also we have seen that it is comprising of a core and it was having three orbits. And the lastmost, otherwise the highest occupied orbit in the atom is called as what? The valence band. Okay, and even beyond this valence band, the band is called as the conduction, uppermost band. Here. And about the valence band also we have studied that it will be having fully filled, otherwise partially filled electrons, where the electrons even in the ordinary temperature can jump from the parent atom to the conduction band. And such electrons will be called as the free electrons that will be responsible for the production of electron current. Here, and then we move to the energy band, energy level diagram. Okay, in the energy level diagram, we have studied the three types of factors here, otherwise three types of terms here that are called as the valence band, conduction band, and the fundamental energy gap. The energy level occupied by the free electrons is called as conduction band. Energy level occupied by the valence band is called as the valence electrons, and the separation of the valence electrons and the conduction band is called as what? The forbidden energy gap, and the forbidden energy gap is measured in EV, that is electron volts, right? All these important things about the structure of the atom as well as the energy level diagram, where we have studied about the valence band, conduction band, and forbidden energy gap is very important. Now we will move to the classification. This is very important for 5 marks. Classification of solids based on energy band diagram. Classification of solids based on energy band diagram. Okay. The solids are basically classified as conductors, okay, semiconductors, and insulators. So the solids are basically classified as what? Conductors, semiconductors, and insulators. Right? So here we will be observing the forbidden energy gap, otherwise how each solid, that is conductor or semiconductor or insulator, are different from one another by their energy band diagram. So first we will start with the energy band diagram of the conductors, where it is having a valence band, okay, this is the valence band, and this one is the conduction band. This is called as the conduction band. And the energy level is measured in terms of electron volt. Here, for the conductors, we can clearly observe that there is not at all any gap between the valence band and the conduction. We cannot observe any gap between the valence band and the conduction band. They are completely overlapped. Okay. Are overlapped. Okay. So this valence band and conduction band are completely overlapped. There is no forbidden energy gap. Hence, the electrons from the valence band can freely move to the conduction band, even if no external source is given, even in the ordinary temperature, and it requires very small amount of voltage for the conduction of the electrons easily. Right? Examples for the conductors are copper, aluminium. So I'm writing here examples are copper, aluminium, gold, silver, so many. Silver, gold, many metals are there. Those are called as conductors. Right? So what we need to understand here is the overlapping of the valence band and the conduction band, and there is no gap between the the valence band and the conduction band. There is not at all any forbidden energy gap in the conductors, right? And conductors are the solids, otherwise the materials in which the electron current can freely, that allows the electric current to freely flow through them, are called as what? Conductors. The materials, otherwise the solids, which freely allow the electric current to flow through them or electric charge to flow through them, are called as what? Conductors. There is no forbidden energy gap, so very easily the electrons from the valence band will jump to the conduction band to form the conduction. Even in the ordinary temperature or without any external source, some electrons move to the conduction band, and a very small amount of external voltage can easily make the electrons to flow from valence to conduction band, hence conducting the electrons or making a current to flow through them. Okay, so this is about the conductors here. So we are talking about the conductors here, and examples are copper, aluminum, silver, gold. Many metals are there. Iron also we can say. Now moving to the semiconductors. In the same form, we need to draw the energy level diagram, where this is the valence band. And this is called the conduction. And this is called as 1 electron volt. There is a forbidden energy gap of 1 electron volt between the conduction band and valence band, and a very small amount of otherwise a applied voltage can make the valence electrons to jump to the conduction electron, and it also depends on the temperature. Yeah. Variation in the temperature can also make the valence electrons to jump to the conduction band, because the forbidden energy gap is less. There is a very small forbidden energy gap. That's why electrons from valence band can jump to the conduction band, but with some external source. Right. So, what are semiconductors? Semiconductors are the materials whose conductivity lies between the conductors and insulators. So, they can be operated as conductors or insulators depending on the applied voltage and also depending on the temperature. Okay. And the example for semiconductor, silicon, most popular ones, silicon and germanium. Silicon and germanium are the two most important examples. Clear? So this is about semiconductors. What we need to understand, what we need to take from this figure is that this gap of 1 electron volt. Okay, this is the forbidden energy gap. This is the forbidden energy gap, and the forbidden energy gap for semiconductor is approximately 1 electron volt. Approximately 1 electron volt, whereas for the conductors there is no forbidden energy gap. They are completely overlapped. The valence band and conduction bands are overlapped. The electrons can freely move between the from the valence to conduction bands. Okay. Now about the insulator. There is a big gap between the valence band and the flux. 5 electron volts. Okay. Comparing to 1 electron volt, a really big value. So, what are insulators? They do not allow electric charges to flow through them. To flow through them. They will not allow any charges, otherwise electric charges to flow through them. Are called as what? Insulators. These are called as what? Insulators. And insulators are having a large forbidden energy gap called as measured as 5 electron volt. As the gap is very high, even when external electric source is applied or any external factors are applied for the electrons to make from the valence band to jump to the conduction band, they cannot jump because of a very large gap. Hence, as the electrons completely do not jump from the valence band to the conduction band, there are no free electrons at all. Hence, there will be no constitution of the what we can say no current will be constituted. Simply, no current will be resulting. That's why these are called as insulators, and insulators are basically the materials that are that do not allow any charges to flow through. They will be not allowing any charges to flow through them. And why it is happening? Why they are not able to allow the charges, electric charges, otherwise the electric current to flow through them is due to the gap, the forbidden energy gap. What this gap is called? Forbidden energy gap. And this forbidden energy gap for insulators is very high, in order of 5 electron volt. Hence, it will not make it suitable for the electrons present in the valence band to jump from the valence band to the conduction band, and hence no free electrons. When no free electrons is definitely no electric charge flow, no flow of electric current through them. Such materials are called as what? Insulators, and examples are many and many. Wood, plastic, rubber, ceramic, and so on and so on. Okay. Any materials that do not allow the electrons to flow through them, right? So this is what we have studied about the energy band, the band theory of semiconductors, the solids, where we are basically studying this band theory to clearly understand about the semiconductors. So in the further topics, we'll be dealing further about in detail about the semiconductors, right? So in the semiconductors, we'll be studying about the structure of silicon, because silicon and germanium are the two important semiconductor materials, because most of the semiconductor devices are manufactured based on silicon and germanium. So studying the concept, otherwise the band theory, otherwise the internal arrangement of the electrons for the silicon as well as germanium is very important here. And in the valence band, while studying about the semiconductors and specifically studying about the germanium and silicon, we come across that the valence band is a tetravalent. That means it is having 4 electrons. Okay. With that, we will move to the concept of doping, where doping will result into two forms of semiconductor substrates called as p-type and n-type. All these concepts in detail we'll be studying in the further topics. For that, we need to understand this basic structure of atom and the terms called as the valence band, the conduction band, arrangement of the electrons in the orbit. Also, we need to understand that everything further in the next class, right? So, in the silicon and germanium also you will study that, you will study the arrangement, and also you will study about the grouping. Okay? That will result into formation of more free electrons, otherwise more holes. Okay, that forms p type or n type. All those detailed concepts will be studied there. Here, so up to the classification of solids based on the energy band diagram I have covered in today's class. In the next class, we will proceed with the semiconductors. More and more about the semiconductors, the properties of semiconductor, right from the definition of the semiconductors and all. We will start studying in detail about the semiconductors in the next chapter. So in today's chapter, what we have, in next class, in today's class, in this chapter about the semiconductors, what we have studied, semiconductors are very important for understanding because most of the electronic components are semiconductor based. Even the advanced techniques are developed based on the concept of semiconductors, right? So for that reason, we are going to study the semiconductors in detail, right? So what all we have studied? We have studied the band theory here, and in the band theory we have studied the atomic structure, the structure of atom, about the core, the fixed orbit revolving around the core, otherwise the nucleus, called as the free electrons, right? The energy level occupied by the free electrons, band 1, band 2, and the valence band. Beyond that, the conduction band. The electrons present in the conduction band is called as the free electrons. Okay, these are called as the valence electrons, or the valence electrons present in the band is called as what? Valence band. And the definition of conduction band. All this we have studied, right? So in the next class, in the tomorrow's class, we'll be studying further about the semiconductors. So this is all about today's class, students. Thank you.